everyone, welcome to this episode of Grease and Gas. We're here at Lilow Auto Tech with Ian, who's like a Rain Man of hot rod builders. Ian, run us through basically what goes on here and how you create these chassis rails and sort of what you're doing here with your own personal roadster.
Well, welcome here, guys. It's first bit of royalty we've had in the last 20 years, thank you. We'd like to, well, first of all, what we predominantly do here is design and build chassis rails to cater for Fords, Chevs, Willys, and Model A Fords as well, plus some other different variable models. So in other words, they're all planned out on CAD, on computer work. The drawings are pulled up into cutting programs. The rails are cut, assembled, tack welded together, then they go into a welding machine, which we have to compile the welding programs to allow it to weld as well. So therefore it produces rails that we put underneath the likes of this roadster here.
That's it. And you use various different front suspensions and rear suspensions. Seems to be a lot of like Jag rear ends here.
The Jag rear ends become. Well, I grew up with an S-type rear end in my roadster back years ago, and they've sort of followed me for a lot of cars that I have built in the past, in the last 30 years. So therefore, it's probably a familiar pattern. I don't mind them.
And you're definitely happy with, you know, their geometry and the way they travel.
The geometry works,
and all that,
and you can get a limited slip diff in them as well, like the S-types. Most of them are at limited slip, 355 ratio or 377 ratio, which is good for the hot rods.
That's it, So what we're looking at here is a 4-link front suspension, which is...
The 4-link, this one's got a 5-inch drop axle, it's got SoCal brakes, which they supplied Willwood. It's got polished stainless steel, original style forward spindles, stainless steel perch bolts, just a normal standard combination hot rod front end. But this time we're using a Chimera rack on the back of it for steering.
So there is a useful part from a Holden Chimera.
Yes, there is.
Wow, you heard that first. There is something, other than recycling them.
The body here is just a reproduction Brookville body. Came to me through a trade from a roadster pickup I had. So,
all steel, definitely.
All steel, original tank, original firewall. That's about it. So,
would this normally have had timber framework inside it, or like
the Aussie body ones had timber. This is going to be fitted with original Harler branch. These ones here, which I've got off a guy from New America.
Yeah, definitely a beautiful wheel. The rear one's looking unreal. They look unreal.
The rear ones here are 15 by 10s, they're 15 4s, 4.5s.
And when you put these chassis together, do you need engine combination, transmission to roughly know, or they're things that get welded in later, mounts and transmission cross members?
A lot of the design now has to be designed around what transmission, not so much the motor, but transmission, because you go to LS motors and the 6-speed transmissions are big and bulky.
Huge gearbox,
400s are hard to get in sometimes, but we've managed to get them in, no problems at all.
All right. And Greg will have shown you the little step on the chassis rails of this particular car. We're going to show you how that's done. We're not going to do it, but what sort of machinery and effort is involved in doing that and not ending up with just a flat-sided sort of chassis rail. That gives it some shape and some character. Now, what are we looking at here? This is for a customer from where?
This is South Australia guy. This is a 34 coupe. Body was originally built by Juice Customs. It's fitted with a tub, what we call a pre-tub chassis, which is 3 inches tubbed in the rear each side and 2-inch raised on the rear as well. Just a normal standard repo rail, except for the tub work. Got a Rod Tech front end,
Yep.
We fitted with Wilwood brakes. It had a Windsor motor in, but what will be going in here is the Dart cleaver block.
Yep.
It's Higgins heads, blower manifold, 1071 and birdcatcher on top. So
beautiful. And the setback in the firewall, is that normal or that just...
had to be.
Had to be, yeah.
Had to
also,
be.
do you, like, because this is going to a different state, are you in sort of contact with possibly his engineer? Or
Yes.
You are, right, yeah.
Most times we tend to work with them if we can,
Yeah. No, this one's going to be a tough car with a 9-inch and 31 spline axles, floaters.
Full floating hubs, Wilwood brakes, everything brand new. Yeah.
No, definitely going to be a killer car and a full fended car, because you'll notice if anyone's wondering what all the bolts and hardware sticking out of the chassis is, just to mount all the running boards and full fenders.
Just to get the fenders in. This had to be split 40, I think it's 45 mil.
Yeah.
Just to get them in position. So these have got to be finished off yet.
Definitely keep an eye out for this one. It's definitely a very mean looking hot rod, this one. So we'll go over to this masterpiece. I'm thinking it's a rough masterpiece, I reckon.
I like this rough masterpiece.
It just about is. I'm fascinated with the stuff you've done under this car. These rear control arms, and explaining the Watts linkage and how that's working, and not really shock absorbers. It's sort of like, what was it, a friction shock absorber?
Shocks on it.
Yeah.
There's brand new repo Model A spring in the rear. The championship change diff came from Limeworks in America.
Yep.
I sent a chassis over with rod bods, and they sent the diff back to me in exchange. The aluminium radius rod you see there, machined out of 20mm aluminium 5083 plate. It's had an FEA on it, which is a finite analysis. Passed.
But you would have a rough idea on the type of material you'd at least want to start with.
Exactly.
Yeah.
You've got to have to know.
Yeah.
So I showed you the panhard bar arrangement before.
Yeah, that was amazing. Yep. But this is all stuff I've never seen before. I'm used to, it's either coney shocks or coilovers, and like a Watts link is to me like what I remember under an XF Falcon.
Well, it's about time you got out of the city.
We do it. Yes. Imagine he's become a smart ass since they got electricity here in Shepparton.
We can do a lot with electricity. Government doesn't take it off as say.
Yeah. And the front end in this is quite unique. It's not quite a 4-link. It's not quite your hairpin front end either.
This is I've had that front axle for probably 30 years. It's a 5-inch dropped axle.
Yeah.
Magnum axle it is. Split wishbones here.
Yep.
Lever action shocks again. We've got these are original 39 Ford stubs. I think came off a guy's car for 39 coupe in Queensland back in 1976.
Yeah.
So I've machined them now to suit the.
So it will never have front brakes, or?
Well, depends how game you are, I think, really.
I do sort of understand that certain brake companies and that, like especially in a drag racing application, because you've got such a wide rear tyre, you want more brakes towards the back. Does that sort of sound?
No, you should always have bigger brakes on the front.
Righto.
Yeah. Mandatory.
All right, and we've got a blown Cleveland in this one.
Blown Cleveland.
Yep.
The carbies actually came off Frankie Flatout Roadster that's out the front there.
Yep.
They came off Warren Wilkie's old 30 model Roadster, the top Australian show car from 1973.
Yep.
Righto, so I bought that off him.
And none of you polished them.
First time I put a kit in it for 5 years. So
No, she's definitely a pretty wild looking thing. I don't think you'd want to paint this, would you?
No, the body came from a guy from Castlemaine who passed away.
Yep.
That's
Is
why
that steel, that one, or?
That's American fiberglass body.
Okay, yep.
So in other words, I left it with the original black colours and yellow firewall mark with respect to him, you know. So
Yep.
yeah.
No, I think it looks wilder like that.
I might have to try and fire it up for you later.
That'd be great.
Would you?
Yeah.
All right, we'll see what we can do.
Better than you trying to shove my arm under some sort of laser cutting machine. Like, Jamie, let's get a grease and gas tattoo. Yeah.
I don't know.
And what we're looking at here is the beginning of Ian's custom chassis rails, and this machine has various programs that he's probably put in it or got to put into it. And yeah, it's definitely increased production since electricity came to Shepparton. If you want to just run us through, because you basically created this machine yourself over a fair period of time, and yeah, just run us through what it took to sort of get this done.
This machine came about because of a company, Australian Robotics, was just starting up in about 1998, I think it was. And I had a demo in '99 regarding possibly purchasing a plasma cutter. They brought a demo to the place I had out of town here a bit. A 1200 by 1200 table at the time with plasma cutter was $38,000, right?
Yeah.
There's no way I known. I didn't have any work, I couldn't do anything. So therefore, I thought to myself, if they could do it, I could do it, right?
Yeah.
The only reason I took it on, it took me 12 months to understand, configure the electronics, the software, everything else like that, plus build it and run it. I commissioned it in 2000 when they said all computers are going to go haywire.
Yeah,
right?
yeah.
Was that was a bit of a test. So nothing happened. So this machine has been running since 2000 until now, which we just showed you some cutting before. Been a couple of modifications to it, mainly CNC controls and the torch height controls.
Yep.
Now, I have developed my own arc voltage or torch height control that monitors the arc gap between the cutting head and the material surface.
Yep.
And this has increased the cutting consistency.
Yep.
Probably by about 50 to 80% on what a normal plasma would cut at.
Yep.
Which we showed you before.
Yep.
And you look at the cut as it's lifted out.
Yep. And you can,
there's no dross effect or anything like that.
No dramas there.
So that's been a bonus.
And I don't even know how you would wrap your head around the electronics on this. Did you have any sort of formal training on this, or it's just something that you absorb and understand somehow? And
what was Lucas? Lucas made. If the smoke's going to come out, voltage has got to come in.
That's like us when we do electrical work, Greg. Just put the positive terminal on, and if there's no smoke, we can keep going.
Over time, I have shut down a couple of power supplies.
Oh right, yeah.
Physically,
so
learn not to do it.
Yeah, no, it does the job. It does it really well, and it's very accurate.
Possibly, when I built this, no one was into the TIG welding to start with.
Yep.
On the chassis work, no one was into the plasma cutting or in-house plasma cutting.
Yeah.
They outsource it or go and cut it by hand like I had 2 years ago.
Yeah.
But nowadays, a lot of engineering fabrication shops do have their own plasma cutters, machines to cut, polish, do whatever.
Yeah. And like this machine and some of the other ones that you've got, like we discussed, it also helps you build people because you know what it's going to do. You know it's not going to waste the material, especially in the welding side of things.
The cost of material since COVID, it's gone up 60 or 70%, so you cannot waste it anymore.
No, that's it. You've got to use every single bit of it. And what comes off this, does it get recycled at some point, or like the offcuts that you just get to a point where you can't use any more of it?
Well, garden art.
Oh yeah. We are in Shepparton. We are in Shepparton.
Right. Yeah. So
the better, more of us, the better.
Yeah.
All right. Well, we'll move on over to the amazing welder that you've created.
Tick trap.
All right, we're over here where the magic happens, and all these cut pieces that form these chassis rails get basically finally welded together before they get dressed and what have you, with linishing and what have you. And this is another welding machine that you've created.
Yeah, a little bit. We had a couple of crew of guys, 2 or 3, welding these chassis rails together for 10 years at least. But after about 3 years, you see, it takes a lot of skill, energy, everything like that to consistently produce the rails.
Consistency.
To hand weld them. So therefore, back in 2003 or 4, I started to design this machine to take the welding process away from the individuals.
Yep.
So there's no human error that comes into it.
Yep.
So this took 7 years of after hours to put together, because it's a lot of fine work in it and understanding of how heat expansion works.
Yep.
Like even in this head here, I think I've had 5 different heads on it because the heat was destroying all the linear bearings in it.
Yep.
Condensed heat, so we had to cut profiles into them to let the air expand around it, or dissipate the heat. So it's a lot of little things, you know.
That's it.
But on this, come back here.
Yeah. And again, as you can see, this is not just a flat sheet of steel that's trying to be welded. There's so many variations in what this welder's got to do.
This is actually a true 3D process.
Yeah.
3-dimensional, get that in your head, X, Y, and Z, up and down.
Yeah.
So therefore, it all works in conjunction with the program, as in fully welding in 3D.
That's
complete.
it. Yeah.
It could be the only 3D welder in the world. I'm not sure. I cannot find another one.
Yeah.
So therefore, it has got some credibility in it.
We're happy to start some trouble. This is the only one. Okay.
Yeah. So, but anyways, there's a lot of things gone into it. It had to be quick release, so you can move around the table quickly. You've got all these like this. It's all operated by air in that way.
Yep.
You've got this here is either slow on the torch eye control, or you can speed it up to move it into position quickly, you know.
Yeah.
So therefore, you've got all that. All the programs pull up through the computer into a screen, which you see here, which is...
Yeah, you can literally see where the welding head has been and where it's going.
Around into your 3D profile.
Yeah.
It's just one of those things. You got Y feeder in here.
Yep.
This here's got all the torch eye control pieces.
Yep.
That's needed.
Yep.
That's my own design. I mean, that works in every machine here at the moment. So yeah. So
it's definitely a good starting point on a lot of these machines to control them. Yeah, it seems like it. And this machine's actually using the welder and gas bottle over there, but that's sort of set at its maximum so that you can turn things up or down here.
This will all turn up and down because of this. This is like an amp control.
Yep.
So for the TIG welder.
Yep.
You can adjust all your wire feeds down inside here.
Yep.
Things like that. You can adjust your height control from the tungsten there, the TIG torch to the height. You can adjust it on the fly all the time.
That's it, yeah. So that machine over there sort of set at a base setting, and Ian would just make the adjustments as he sort of sees them and hears them even too, the weld, like we were saying, and just the sound of it tells you it's doing the job.
After doing all the welding from 79, you know when a weld's going well.
Yeah.
Yeah, so.
Yeah. And like you can see here, it's there's a bit extra on there so that you can linish it and take it back to a nice
You normally tell by the weld,
Yep.
if it's hand welded, machine welded. This is machine welded, so you get the continual
the
line
colour's very consistent there. Yeah.
So,
do I sound like I know what I'm doing?
You do.
Yeah, this is because we already went through this 3 times.
I've got 5 sets for you to build tomorrow, mate.
All right, no problems. But yeah, like you can see, it is not a straight chassis rail. This has shape to it that follows the contours of your roadster bodies and what have you. So that machine has to manage all of that, doesn't it? Yeah.
There's probably inside there what programs you've got, because you need, for every rail produced, you need a lower welding program.
Yep.
Need the top part of the welding program.
Yep.
Multiply that by lefts and rights.
Yeah.
So therefore, if there's 50 styles of rails in there, there's 200 programs in there.
Yeah. That's it. Yeah.
You did add that up, didn't you?
Yeah. I'm just glad this computer's only used for that. We don't have to go through Ian's search history.
You're right.
That's it, and this is it. This is the amazing thing that gets these chassis rails together, and it's the only one in Australia, or in the world. World, sorry. All right. And yeah, you saw it here on Grease and Gas. A reveal. All right. And it's typically on a 28, 32 chassis?
32 is the only ones that had it.
All right, yeah.
So 32's got a reveal along the length of the rail underneath the body.
Yep.
The running board sits on this side, down below here, the body sits this side.
Yep.
So therefore, you've got to try and roll this material to create that reveal.
Yep.
There's no other way to do it without building $1 million press, which American Stamping, all those people do.
Yeah.
But the one thing about all those rails, they cannot get this curve.
Yeah.
An original rail, 32 rail, had 1/8 of an inch curvature between that point and that point.
Yeah.
If you look at all the reproduction rails, they're flat.
Yeah.
In that area.
Yeah.
Which leads to other processes of buckling of the rail.
It makes a lot more body work required for a chassis rail that it shouldn't need it.
Sometimes they can pull flats in it.
Yeah.
So what the rail gets put in this way.
Yep.
Then this gets lifted down. Then you just
and then the heavy duty work starts.
Crank it.
Yeah. So if you ever wondered how the reveal on the side of a 32 Ford chassis gets done here anyway,
that's
this bit of equipment here. Get a greased and gas tattoo, they said.
Keep the arm straight.
Yep.
That way.
You do it.
Right there. That goes up here.
Yeah, all right.
No function, no function.
Yeah, I know. Ian's a genius, but he's a pain in the ass. Just feel it in the hair.
Can you?
On the forearm. Just. It's not touching the skin. I'm not sure what it looks like on camera, but it's not touching the skin.
Yeah, right. Let's get you a shave, won't we? So do you want to go that way?
You get a broken nose from this. My arm's fine, but my nose is broken.
Beautiful.